Welcome, friends. How are you all? I hope you are all good. We have been started Thermodynamics 1000 plus MCQ series, and we have been reached at set 5. One set includes only 30 question, and we will cover 1000 plus MCQ in this thermodynamics series. In this set, I mean that is set number 5, I have included some questions from SSC JE 2019 September, that was dated 25th September 2019 and shipped 2nd. So let's begin with the set 5. If anybody haven't seen watched my previous videos, that is set 1, set 2, set 3, set 4, that can visit the link in the description below. So let's get started. Now question number 121 is: the air-fuel ratio used in normal operation of SI and CI engine are the air-fuel ratio. This question has been asked in SSC JE 2019 25th September, shift 2nd. We have four options: excess air for CI, that is diesel engine, and around stoichiometric spark ignition engine, that is petrol engine. Option B, excess air for CI and SI. Option C, around stoichiometric for both SI and CI. And option D is a very rich mixture for SI and lean mixture for CI. So its correction answer is D, very rich mixture for spark ignition engine and lean mixture for compression ignition engine. Next question 122. Select the incorrect statement from below. We have to find out the incorrect statement from below. That question was asked in SSC JE 2019 25th September, shift 2. Option A, suitable thickness of the top of the piston is needed to provide sufficient bearing area for side load. Option B, piston rings are present to prevent gases of combustion from leaking out. This is also right, I think. Option C, oil rings are present to seal the combustion space from leakage of oil. This is also right, I think. Option D, piston pin is used to connect piston and connecting rod. This is also right. So its incorrect statement is option A, that is suitable thickness of top of the piston is needed to improve sufficient bearing area for side load. Let's move to the next question. An ideal gas undergoes an isothermal process between stage 1 and 2. The appreciable equation is the question asking isothermal process for isothermal process for ideal gas. So in this figure you can see this process is from number 1 state to number 2. This is isothermal process where PV is constant. So we have the answer B, P1 V1 is equal to P2 V2. An ideal gas undergoes an isothermal process between state 1 and 2. The applicable equation is P1 V1 is equal to P2 V2. This question has been asked in SSCJ 2019 25th September, shift 2nd. Let's move to the next question. A reversible heat engine receives 240 kilojoule per second heat from a source at 627 degrees Celsius and rejects heat to sink at 300 Kelvin. The available power is option A is 160 kilowatt, option B is 20,000 joule per second, option C 80 kilojoule per second, and option D is 100 kilowatt. So we have here many things to remember. This is the reversible heat engine. First is that reversible heat engine. Keep in mind that the engine is reversible, so its answer must be A. And how? You can see in the equation and the diagram. We have made the diagram for the reversible engine. This is the power output, this is the Q1 heat, this is the Q2, this is the 900 Kelvin, and this is the 300 Kelvin. So 900 came from the 627 degrees Celsius. If we convert it into Kelvin, then plus 273 in 627, then it becomes 900 Kelvin. So if you're wondering how this equation appears in this, so we have a relation. We have a relation. Efficiency is equal to work done divided by Q1. Okay, always remember that efficiency is equal to work done divided by Q1. So efficiency, we know that how to calculate. This is the T2, this is the T1, because this is a reversible cycle, and T2. So this is simple. Efficiency is work divided by Q1 is 240 kilojoule per second. If we solve this equation, we have the power is equal to 160 kilowatt. This question has been asked in SSC JE 2019 25th September shift 2nd. Let's move to the next question. If a dry saturated steam is admitted to a steam turbine following an isentropic process, at the exit of turbine will be a wet stream, option B superheated steam, option C dry saturated steam, and option D liquid condensate. So its answer must be wet steam. At the exit of the turbine there will be a wet steam. Next question is, the gas turbine cycle with regenerator improves option A thermal efficiency, option B work ratio, option C avoids pollution, and option D is none of these. So answer is thermal efficiency. The gas turbine cycle with regenerator improves thermal efficiency of the cycle. Next question is, high air fuel ratio in gas turbine, what happens? Option A increases power output, B improves thermal efficiency, C reduces exhaust temperature, and D do not damage turbine blades. So its answer is reduces exhaust temperature, high air fuel ratio in gas turbine. So answer is C. Next, the fuel mostly used in steam boiler is, I think one of the basic and important question. We have four options. Option A brown coal, option B peat coal, option C coking bituminous coal, and D non-coking bituminous coal. So its answer is non-coking bituminous coal is the fuel mostly used in steam boiler. Next question is, the principal constituents of fuel are, very basic question also. So its answer is carbon and hydrogen. Everyone knows this is the most basic question. Next question, the fuel mostly used in cement industry and in metallurgical processes is, we have four options. Option A wood charcoal, option B bituminous coke, option C pulverized coal, and option D is coke. So fuel mostly used in cement industry and in metallurgical processes is pulverized coal, option C. is answer. Next question. The amount of heat generated per kilogram of fuel is known as option A calorific value, option B heat energy, option C lower calorific value, option D higher calorific value. So its answer is calorific value. The amount of heat generated per kilogram of fuel is known as calorific value. The answer is A. Next, which of the following has the highest calorific value? We have peat coal, lignite coal, bituminous coal, and anthracite coal. So we have to find out which of the following has highest calorific value. The answer is anthracite coal has highest calorific value among the ABC. Next question is, the fuel mostly used blast furnace for extracting pig iron from iron ore is option A hard coke, option B soft coke, option C pulverized coal, and option D it's bituminous. So its answer is hard coke is used in blast furnace. Most important question also. Next question is, the blank is obtained when carbonization of coal is carried out at 500 to 700 degree Celsius. We have four options. Option A soft coke, option B hard coke, option C pulverized coke, and option D is bituminous coal. So answer is A, that is soft coal. The soft coal is obtained when carbonization of coal is carried out at 500 to 700 degrees Celsius. Next question is, carbonization of coal consists of, we have three options mainly here. Fourth option is none of the above. Carbonization of coal consists of option A drying and crushing the coal to a fine powder, option B molding the finely ground coal under pressure with or without a binding material, option C heating the wood with a limited supply of air to temperature not less than 280 degree, and option D is none of the above. So answer is none of the above. Next question, coke is produced. We have four options here. When coal is first dried and then crushed to a fine powder by pulverizing machine. Option B, from the finely ground coal by molding under the pressure with or without a binding material. Option C, when coal is strongly heated continuously for 42 to 48 hours in the absence of air in a closed vessel. Option D, by heating wood with a limited supply of air to a temperature not less than 280 degrees Celsius. So coke is produced when coal is strongly heated continuously for 42 to 48 hours in the absence of air in closed vessel. That is called carbonization. In the previous question, the question was carbonization of coal consists of these statements, but none of the above was correct. Why? Because there wasn't the option that matches the carbonization of coal. Then I submit this question for the next, that it can be clear what is the carbonization. So carbonization is strongly heating continuously for 42 to 48 hours in the absence of air in a closed vessel. That is called carbonization. Next question is 137. The hard coke is obtained when carbonization of coal is carried out at, option D is the answer, 900 to 1100 degrees Celsius. The hard coke is obtained when carbonization of coal is carried out at 900 to 1100 degrees Celsius. Next question is, when wood is heated with a limited supply of air to a temperature not less than 280 degrees Celsius, the resulting fuel is, we have option A coke, option B wood charcoal, option C bituminous coal, option D briquetted coal. So its answer is bituminous coal is obtained by this process. Next question, when coal is first dried and then crushed to a fine powder by pulverizing machine, the resulting fuel is called? Option A, wood charcoal. Option B, bituminous coal. Option C, briquetted coal. And none of the above. The answer is none of the above, because this is called pulverized coal. You can see uh, there is mentioned pulverized machine in the question, so we can find out it can be pulverized coal. Next question is, the natural petroleum may be separated into petrol, kerosene, fuel oil, and D is lubricating oil. So option D is the answer, that is lubricating oil. Next question, petrol is distilled at, we have four options. Option A, 65 degrees Celsius to 220 degrees Celsius. Option B, 220 degrees Celsius to 345 degrees Celsius. Option C, 345 degrees Celsius to 470 degrees Celsius. And option D, 470 degrees Celsius to 550 degrees Celsius. So petrol is distilled at 65 degrees Celsius to 220 degrees Celsius. Next question, which of the following gas has the highest calorific value? We have four options. Option A, coal gas. Option B, producer gas. Option C, Mount gas. And option D, blast furnace gas. So its answer is coal gas. Coal gas is the highest calorific value among the B, C and D. Next question is, we have discussed the distillation temperature of petrol. Now this question asks distillation temperature for kerosene. The question is, kerosene is distilled at option A, 65 degrees Celsius to 220 degrees Celsius. Option B, 220 to 345. C, 345 to 470. And D, 470 to 550. So answer is 220 degrees Celsius to 345 degrees Celsius. Kerosene is distilled at this temperature. Answer is B. Next question, steam coal is a, we have four options. Option A, pulverized coal, brown coal, coking bituminous coal, and non-coking bituminous coal. So answer is non-coking bituminous coal. Steam coal is a non-coking bituminous coal. Option D is the answer. Next question, the ultimate analysis of coal consists of the determination of the percentage of option A, carbon, option B, hydrogen and nitrogen, option C, sulfur and ash, option D is all of these. So answer is all of these. The ultimate analysis of coal consists the determination of the percentage of carbon, hydrogen, nitrogen, sulfur and ash. The answer is D, all of these. Next question is, the distillation carried out in such a way that the liquid with the lowest boiling point is first evaporated and recondensed, then the liquid with the next higher boiling point is then evaporated and recondensed, and so on until all the available liquid fuels are separated, recovered in the sequence of their boiling points. Such a process is called option A, cracking, option B, carbonization, option C, fractional distillation, and option D, full distillation. So answer is, that is called fractional distillation. Next question is, a process of heating crude oil to a high temperature under a very high pressure to increase the yield of lighter distillates is known as option A, cracking, option B, carbonization, option C, fractional distillation, and option D, full distillation. So answer is cracking. This process is called cracking. Next question, producer gas is obtained by, we have four options. Option A, partial combustion of coal, coke, anthracite coal or charcoal in a mixed air steam blast. Option B, carbonization of bituminous coal. Option C, passing steam over incandescent coal. Option D, passing air and a large amount of steam over waste coal. at about 650 degrees Celsius. So its answer is A. Producer gas is obtained by partial combustion of coal, coke, anthracite coal or charcoal in a mixed air steam blast. Next question is, now Mond gas is obtained by, we have four option here. Option A, partial combustion of coke. This cannot be, that is the definition for the producer gas. Option B, carbonization of bituminous coal. Option C, passing steam over incandescent coal. Option D, passing air and a large amount of steam over waste coal at about 650 degrees Celsius. Okay, this is overwriting here, I'm sorry for that. So its answer is D, passing air and a large amount of steam over waste coal at about 650 degrees Celsius. Now next question is, which of the following is the lightest and most volatile liquid fuel? Lightest and most volatile. We have four options. Option A, gasoline. Option B, kerosene. Option C, fuel oil. Option D, none of these. Answer is gasoline, that is petrol. Next and last question, dear friends, if you any any one of these questions, don't forget to hit the like button. So last question is, which of the following statement is incorrect? We have to find out the incorrect statement from the following statement. Statement first, A, the liquid fuels consist of hydrocarbons. B, the liquid fuels have higher calorific value than solid fuels. Option C, the solid fuels have higher calorific value than liquid fuels. And option D, a good fuel should have low ignition point. So its answer is C, that is solid fuels have higher calorific value than liquid fuel. This statement is the wrong statement. So friends, thank you for the watching of set 5. Soon we will bring the set 6 and I will try to bring out the question that has been asked in previous SSC JE examination. And if you like this video, don't forget to subscribe my channel and hit the bell icon for the notification of new video and like the video also. Thank you very much.